This video will cover how to set up the lock-in configuration for the first and second generation of basic fiber photometry systems. The fluorophores for fiber photometry have specific excitation and fluorescent wavelengths, which are important to know when setting up the lock-in configuration. In addition, the isobestic signal, which is calcium independent, is commonly used to control for motion artifacts, especially with G-cam recordings. Before setting up the lock-in, it is important to understand how the system is connected. In this example, two second-generation minicubes are used to record two fluorophores at two different sites. Let's take a look at our system. We have three analog outputs. Analog out 1 is for the isobestic excitation, analog out 2 is for G-cam-like excitation, and analog out 3 is for R-cam-like excitation. The console also receives four analog inputs. Analog in 1 and analog in 3 are the combined isobestic and green signals from the F1 port of each minicube and will be demodulated within the software. Analog in 2 and analog in 4 receives the R-cam-like signals from the F2 port of each minicube. With this understanding of the system, let's open Doric Neuroscience Studio to configure the console and the LED driver. First, in the LED driver module, select Add Channel. Make sure that the channel name that you want to configure is correct. Here, LED 1. For the mode, set it to External Analog and check the Low Power Mode box if used in the LED lock-in configuration. Repeat this step for all of the LED channels connected to each minicubes. For our example, we have created 4 channels. If the LED driver isn't connected to the computer, manually set each channel to external analog mode by clicking the knob 3 times. And if the lock-in configuration uses the low power mode, hold down the button for 3 seconds until the minus sign appears on the screen. Next, set up the lock-in configuration in the console module by opening the channel configuration window and selecting Analog In on the left. The channel name here corresponds to the input of the same number on the console. Since the example system today has 4 inputs, we will create 4 separate lock-in configurations. For the mode, specify lock-in. The saturation here depends on the type of detector in use. The Generation 2 minicubes have the Doric detector integrated within them. However, in Generation 1, the detector is external, so choose the appropriate detector. Each column in the lock-in options below corresponds to the analog output channels of the console. For input channel 1, the isobestic and G-cam-like fluorescents are combined, so both corresponding output columns that drive them should be enabled. Here, the trace name represents the analog in number and the analog out number, respectively. We will be able to rename the channel later on. Below are the sinusoidal frequencies that control the LED timing. Each LED has its own frequency required to demodulate multiple signals from one input. We strongly recommend using the default frequency options as they have been optimized for fiber photometry. For the LED maximum current, we recommend using the low power mode because it provides sufficient power for most fiber photometry experiments while permitting a larger dynamic range and more stable recordings. If the low power mode is used here, it must also be set independently for the LED driver. The LED power must be determined by the user since the value will depend on several external factors. Measure the power output at the tip of the fiber with a power meter and change the percentage according to experimental needs. This range typically is between 10 to 100 microwatts. To reduce photo bleaching, we also recommend that the LED power of the isobestic signal be 50% of the green signal. You can always come back later to edit these values. Vmax is automatically modified when adjusting the LED power. Select Add to create the first analog in and its corresponding output channels. This current configuration would work for a simpler system recording only Gcamp and isobestic at a single site. To add the RCamp-like input at the same site, select the analog in2 channel and again the lock-in mode and the detector. Since this input requires the 560nm excitation, we will enable only channel 3. The output power setting should also be measured and chosen individually. Select the Add button to create the second input channel. This current configuration would work for a simpler system recording only Gcamp and isobestic at a single site. Adding a second minikube for a second site is similar to what we've already done. Analog N3 will be the isobestic and Gcamp-like signals, so we can enable these two channels since they are driven by the same analog out as minikube 1. And then for analog N4, enable only analog out 3 once more. Here we finish the lock-in configuration for 2-fluorophore recording at 2 different sites. In the acquisition view of the console module, we can see all 4 input channels. Here, each input has its own window and we can find their corresponding outputs within these tabs. Click Edit to change the LED power. Select Graph to modify the trace name, colors, and formats. To hide a trace, select the empty slot from the drop-down menu. You can organize the view by sliding the different channel windows around. To save this configuration, including parameters, visualization details, and window display, select Save Configuration. If we clear the window, we can quickly load our saved configuration using the Load configuration. Note that a separate configuration should be saved for the LED driver. To begin an acquisition, start all the LED channels in the LED driver module. Then, in the console module, select either Live mode to quickly check the signal, or Record mode to save the data. Doing a dry run, we see that the signals in blue and the demodulated traces in purple, green, and red are all non-zero. Touching the tip of the fiber with a finger results in fluctuation in the channels that receive input from that particular fiber. If the lock-in was properly set up, both the raw signals and the demodulated traces will fluctuate. If you require further technical support, please reach out to us at sales@doriclenses.com.